we are discussing this as a doubt. Okay, so I will just take you through this whole thing once more. Okay, so let's see where we started from and how we reached this point. So the question that we were exploring, was that when we use this kind of formula, so forget about the numerical problem before. The basic question that we were asking ourselves, like these formulae that we have, that you are familiar from 9th, 10th earlier, that v equal to u plus at s, v square is equal to u square plus as, is the value of v instantaneous or not? So the answer is yes, it is instantaneous. So how we understood that is by looking at a particular example. So in this example, if we took the initial velocity as 10 meters per second, suppose, and the acceleration as 2 meters per second square, and we want to find the instantaneous velocity at 10 seconds. Okay. So how I will show that the instantaneous velocity is at 10 seconds is the same that I'll get by using this formula. So how I'll show that is by just using the definition of acceleration. Acceleration kya hota hai? It is rate of change of velocity. So whenever acceleration is uniform, that means delta v by delta t is the same thing as dv by dt, because the acceleration versus time graph will be straight line. So because acceleration is uniform, that means v versus t is a linear graph or a straight line graph. So because it's a linear graph, it means it has a uniform slope. Okay. And that uniform slope is only this thing. It is the acceleration. Okay. So whether we talk about the instantaneous acceleration dv by dt or the average acceleration, that is equal to, in this case, 2 meters per second square. So that means my velocity time graph should be a straight line whose slope is equal to 2 meters per second square. So using this formula, that delta v by delta t is equal to this, we can see that if I go from time 0 to some time t, my velocity is changing from u to some general value v. So the change in velocity is v minus u divided by the change in time, that's equal to a. So that shows us the logic of this formula. And this is showing us that v is nothing but the instantaneous velocity at the instant t equal to t. So that shows us that yes, the formula that we have developed in 9th, 10th, that v equal to u plus at, it is indeed the formula for instantaneous velocity at a particular time. Because the graph is showing us the same. Okay. Now then we were seeing that what is the relationship between the displacement versus time graph and the instantaneous velocity. So what we understood is that without using any formulae, if you use the definition of what is instantaneous velocity is rate of change of displacement with respect to time. So it is ds by dt. So from that graph above, we got that v is equal to u plus at, or in this case, v is equal to 10 plus 2t. So what we can say about s? So v is 10 plus 2t. We have got this as a fact now from the graph. So that means that instantaneous rate of change ds by dt is 10 plus 2t. So if something's rate of change is linear, that means that something has to be a quadratic function, because we know that rule of calculus that when we differentiate a function, the power becomes 1 less. So if we differentiate a quadratic function, we get a linear function. If we differentiate a cubic function, we would have got a quadratic function. So यहाँ पे ds by dt is linear. That means s has to be quadratic. Okay, so using that logic, I can now find out s as a function of time. And when I do that, assuming s is some kind of quadratic function, comparing it with this equation that is given to us and all that, so we find the unknown values of all these coefficients a, b, and c. And we see that, okay, we are getting the value of s as a function of time as this, t square plus 10t, which is exactly what we would have got if we had used a direct formula that s is equal to ut plus half at square. So 10t plus half into 2 into t square. So you can see that this is giving us, so basically again that formula actually comes from this logic only. So now if we want to interpret the displacement versus time graph and what is the meaning of slope of tangent, that is where we see that if we want to look at the displacement time graph and understand from that graph how to get the instantaneous velocity at some point of time. So one option is that we can do this kind of a calculation, that we mechanically take some small value of delta t, like we took 0.1 seconds over here. So we took our t1 as 10 seconds and we took our t2 as 10.01 seconds. And we saw that the average velocity between t1 and t2 came out to be 30.01 meters per second. So this actually we cannot say is the instantaneous value. This is an approximate value of the instantaneous value. because I've not taken delta t tending to 0. I've just taken delta t equal to 0.01. But by improving the maths a little bit further, that instead of taking delta t as some small value as 0.1 seconds, next what I've done is I've taken delta t tending to 0. And tending to 0 karke, I've shown that it should be exactly equal to 30 meters per second. So that means when I draw a tangent for this graph at this particular point, it should exactly have a slope of 30 meters per second. Whereas if I had drawn an approximate tangent by taking delta t as 0.01 seconds, I would have got the approximate slope as 30.01. Okay, any doubts so far? This is clear?
Yes, so clear.
Yes, sir.
Okay, very good. And having done all this now, we understand that because we know differentiation, all these steps are not necessary for us. Once we know the formula and method of differentiation, if I'm given the displacement like this, I don't need to do all these things. I don't need to take delta t tending to 0 and prove all this. I just need to plug in this formula, differentiate this using the principles of differentiation we know. So the moment we know that S is like this, we know that that corresponds to V like this, because differentiation is giving us this. So the velocity at any moment will be 10 plus 2t. So if that moment is 10 seconds, the velocity at that moment will become 10 plus 2 into 10. So it will become 30 meters per second. That's it. That's how simple it makes it for us, right? Okay, now people, any particular question from worksheet 1 you want me to still discuss? I have sent you some hints along with the answers. Okay, so hopefully the hints will, yeah.
Sir,
Yes,
can you please discuss the first question's last part?
first question of worksheet 1, the last part. No, okay, I'll just take you through it. Okay. So just give me a moment. I'll open the worksheet. Worksheet 1 calculus. Share. Okay. Yeah, this G part, calculate the instantaneous speed at t equal to 12 seconds.
Yes, sir. Yes, sir.
Okay. Now see, the thing is, now here, none of the information was given to us in terms of a function. And it's not like displacement is given as a function of time and all that. So we can't really use calculus. Here we have to just use the definition of instantaneous speed, that what it is delta s by delta t for a very small interval of time. Okay. So let's see what information is given to us. It's given that it starts from rest at t equal to 0. So initial velocity is 0. Okay. Its speed increases uniformly at 2 meters per second square for 10 seconds. So this statement now what it means that for t equal to 0 to 10 seconds, the acceleration has a uniform value of how much? 2 meters per second. And u is equal to 0. So this is one bit of information that I have. Okay, and along with along with this, the next bit of information that I have is this, that thereafter, that means after 10 seconds, it decelerates at the uniform rate of 4 meters per second square till it stops. So for this second part, we'll say that from t equal to 10 seconds, okay, to some time which I don't know right now, the acceleration will be expressed as minus 4 meters per second square, right? Because it's a deceleration, right? And
Yes, sir.
for this interval, what is the initial value of velocity? It will be whatever the final velocity here is. And the
20.
final value of velocity will be 0 because it comes to rest. Okay. So just in terms of interpretation, this whole paragraph, it means this, that you can divide the motion into two parts, 0 to 10 seconds and then some 10 to some other time, which I don't know. Now 0 to 10 seconds, what's happening? The velocity is changing from u at the rate of plus 2 meters per second square. And 10 seconds to whatever final time, the velocity is actually reducing at the rate of minus 4, okay, from some initial velocity, which we still have to calculate, to 0. Right, this is clear enough so far? Okay,
Yes,
just a
sir.
moment. Okay.
So
So first
can
of
you
all,
explain what you wrote with green?
how we got the?
Sir, how you wrote what you wrote with green? Can you explain that part?
Yeah, I'll explain that. Okay. So what we know about thereafter. Thereafter means from 10 seconds onwards. Okay, na?
Yes, sir.
And what is given that it decelerates. So decelerates का मतलब क्या होता है? That the acceleration is negative or the velocity is decreasing at the rate of 4 meters. So that's why I've written with minus sign. Okay. And finally, what it is given that until it stops. So until it stops means for this interval, what should I take my final velocity? I should take it as 0. It should be coming to rest.
Okay, sir.
Okay, so that is the logic of this. Okay. So anyway, I've lost the question. Yeah. Now let me explain this. So how we will deal with this information. Okay. So in this question, the information that was given to me. So this is worksheet 1, question number 1. So it is given at t equal to 0. My initial velocity was 0. Okay. And up to t equal to 10 seconds, my acceleration is uniform at +2. So it's uniformly accelerated. Okay. So before we come to the second part, let's visualize this in terms of graph. Okay, we can do by formula also, but just anytime we have a uniform acceleration, it becomes very easy to visualize the velocity time graph because we know that velocity time graph is a straight line. So for the first 10 seconds, you can see how my velocity time graph will be looking. It will be looking like a straight line with a positive slope, no? Because acceleration is positive. And starting from 0 up to whatever velocity it will reach at the end of 10 seconds. So let's say this is 10 seconds over here. And this acceleration is +2. Now you can very easily tell me what will be this velocity. How much should this be?
20.
Very good. Correct. This should be 20 meters per second. Okay. So this part is done. Okay. Now we come to the second part of the motion. What is happening thereafter? So after 10 seconds, t equal to 10 seconds to some other time which we don't know. What is happening? The acceleration is changing to -4 meters per second. It is uniform deceleration. Okay. So when this is starting, what is the state of motion? The velocity is 20 meters per second. We just saw. Because from here onwards, the deceleration is starting. Okay. And when this stops finally, so that means the velocity should become 0. So now how should the second part of this graph look like? It should look like a straight line with a negative slope, right? But starting from this point to some point over here where the velocity will become 0. So let me assume that is this. So this second part, my acceleration has changed to -4. Okay. And my initial velocity is 20 and the final velocity is 0. So now whatever this time is, let's say it's some t prime. What can I say about how much time it's decelerated for? The time for which it is decelerated, the delta t is how much? It is whatever this time t prime is -10 seconds. So change in velocity upon change in time, this should be uniform. So final velocity is 0, initial velocity is 20 divided by some time interval delta t. So that is equal to -4. So how much should this time interval be? It
5 seconds.
5 seconds. So if this time interval is 5 seconds, then what is this time t prime that I'm trying to find out? It is 10 plus 5?
15.
Yes. So t prime should be 15 seconds. So I know that this is equal to 15 seconds because from here to here, this time, this should be 5 seconds. Okay, understood now?
Yes, sir.
Okay, now see that last part of the question was asking you that what should be the velocity, the instantaneous velocity at this time, 12 seconds. So I want to find out the value of the y coordinate of this graph at 12 seconds. I want to find what this v12 is. So can you tell me what is the best method of doing this now?
Taking u as 20 and time as 2.
Yes, very good. So you can see that this time interval is now 2 seconds. Okay. And this interval will become whatever this 20 I mean, whatever this is, it is the final velocity at 12 minus 20. Okay, and the ratio of this by this should be the slope. So this slope should be how much over here? This slope should be -4, right?
Yes, sir.
That's it. So that's now the easiest way of doing this without using any ready-made formula and all. I can see that from t equal to 10 seconds to t equal to 12 seconds. Okay, my delta t is 2 seconds. Okay, now velocity at 10 was 20 meters per second. Okay, velocity at 12, I don't know. So delta v is final velocity minus 20. Okay, but I know that delta v by delta t, that is the uniform rate of deceleration of O. This is the uniform deceleration, which is in fact the slope of that. No? So from that you will see that what we'll get V12 as, we'll get it as 20 minus 8. So we interestingly get it as 12 meters per second. So that is the velocity at this moment. So basically what is this? This is the instantaneous velocity at that moment of 12 seconds.
So I don't need to show this like after finding out the value of V12, do I need to also show it in a like taking t delta t as 0 point something?
No, we don't need to Beta, because we have found the value. No, exactly. We don't need to.
Yes, sir.
You know? Okay. Now, one more thing that this question had asked was the first part, that how will the distance versus time graph look, or displacement versus time graph look. So that will also be a very interesting thing. If we talk about the displacement versus time graph, you can see that it should be having two parts again. 0 to 10 seconds, the distance is increasing in such a way that the slope should be increasing because the velocity is increasing. So it should be a curve which is like this. Its slope is increasing. You can see. So the first part, it should be a curve which looks concave when I see it from upwards because its slope is increasing. But after 10 seconds, what's happening? Now it's decelerating. So the slope of the distance time graph, that should be decreasing. So now in the second part, it should become this type of curvature. The slope is decreasing. And by the time we reach 15 seconds, they should almost become a horizontal line because its velocity has become 0. So that's how the distance versus time graph is. So yeah, what you are asking is now equivalent to this, that do I need to actually draw the tangent here and calculate the slope? Not necessary, because from this, I've got the instantaneous velocity's exact value.
Okay, sir.
Right. Now, if for example, I want to calculate these values, that what is the distance at 10 seconds? Now that easiest way of doing that would be area under the graph. Because you know velocity time graph ka area kya hota hai? It is the distance or displacement.
Yes, sir.
Right, so you can see that this triangle which you get from 0 to 10 seconds, its area would be what? Half of base into height. So that is half of 10 into 10. Sorry, half of 10 into 20. So that would be 100. So it's covering a distance of 100 meters. And the next triangle that you have from here to here, which is in the deceleration part, its base is 5 and its height is 20. So its area will become how much? Half of 20 into 5. So it would be 50.
50.
Okay, so another 50 meters. That means the total
Sir,
distance is covering. Yeah.
So in the first graph, why you took 5 seconds?
Why we took the time as 5 seconds?
Yes, sir.
For the second part?
No, sir. For the first part, you said no. The other half of the graph.
Other half of the graph, the time is 5 seconds. No? See, the other half of the graph is like this. No? The velocity is changing from 20 to 0 in how much time? From time of 10 seconds to 15 seconds. No? So for this triangle, what is the base, the time interval? It's 5 seconds, correct?
Yes.
And this height is how much? It's 20 meters per second. So what is this area now? This area is half into 20 into 5. So it's 50 meters. So 50 meters is the distance it is traveling during which time? From 10 to 15 seconds, the second part of the motion. Whereas this part of the area, okay, going from 0 to 10 seconds. 0 to 10 seconds, as the velocity was going from 0 to 20 meters per second, this area, this is the distance from 0 to 10 seconds. And that came out to be how much? That came out to be 100 meters. So by the time you're reaching 15 seconds, what is the total distance you have covered? You've covered a distance of 150 meters.
150 meters.
So like that. Okay. So this question was not really calculus in that sense. It was more about rate of change and, difference between average rate of change and instantaneous rate of change, right? For example, another interesting part of the question, which I have asked is that how much is the average speed for the entire journey? So now you can see what is the definition of average speed. The definition of average speed is total distance divided by total time. Okay. So if I'm talking about the entire journey, then I have to take the total distance in 15 seconds, divide by 15 seconds. Okay. So this will be S from 0 to 15 seconds divided by the total time of 15 seconds. So which I've just shown you, this is 150. So the average speed for the entire journey is in fact 10 meters per second. Okay, so it's like, a lot of useful sort of general information about distance time graph, speed time graph and all that. And also it's giving you an idea, some kind of conception about what is rate of change. Before we got into the second and third lecture where we saw instantaneous rate of change from differentiation and all that. Before getting into those technical definitions, we just saw from these kind of questions that what is the everyday meaning of instantaneous rate of change, average rate of change and these kind of things, right?
Yes, sir.
Okay. So this will be part of your notes today. So you can, review this solution, but hope your question is clear now.
Yes, sir.
Okay. Yeah, Piyu, to answer your question, this type of question is part of your syllabus, right? But it is part of your syllabus in kinematics. Okay. So definitely it's, part of straight line motion or something like that. And you'll see that when we practice enough questions in kinematics, this is going to be quite easy. Okay. Now I'm just taking you through this worksheet once more. If there's any other question, please let me know. We'll discuss. Okay, so the second question was about that.
Second.
Okay. Yeah, second question is also like something where we have to really think carefully about the language of the question and try and understand what the question is saying. So we have an open cylindrical tank whose base area is given to us. And initially it was empty. Okay. And notice that it's given that an inlet tap is opened to fill water at the uniform rate. Now this rate is given in what? Centimeter cube per second. So this is what kind of rate? It's a volume rate. It is telling me that the volume is changing with respect to time at the rate of 4 centimeter cube per second. That means every 1 second, 4 cc of water is getting added. Okay. And this is happening from 0 to 2 minutes. Or we can say from 0 to 120 seconds. Because after that, again, something else is happening. After 2 minutes, inlet is still open, but the tank also develops a leakage. So after 2 minutes onwards, what is happening is that the rate of change of volume will be actually equal to the rate of inlet, okay, minus the rate of leakage. Because both the things are happening. So the leakage is causing water to leak out. So that means the overall volume of water in the tank is reducing because of the leakage. So that will come with a minus sign, whereas the inlet is filling water. Whereas initially what was happening, there was no leakage. So the rate of change of volume was just equal to the rate of the inlet. It was the rate at which the inlet pipe was letting in water. Okay. So these two statements are clear, no?
Yes,
sir.
And in fact, now when we calculate what is this exact rate going to be, so this is +4, the rate of inlet, but the leakage is happening at double the rate. It's -8. So overall, what will be happening? The volume of water will be decreasing in the tank at the rate of 4 centimeter cube per second after 2 minutes. Now, initial 2 minutes, water is increasing at this rate, and 2 minutes onwards, water is decreasing at this rate. So what we'll see about level of water in the tank, for the first 4 minutes, the level will be going up at a uniform rate because we are filling water at a uniform rate. And then next, what we'll see is that the level starts coming down and exactly at the same rate, because for 2 minutes afterwards, the rate of change of volume is exactly -4 cc per second. And earlier it was exactly +4 cc per second. So it's a symmetric situation. Now, the going up of the level of water and the coming down are just symmetric to each other. So that is something that we can just observe by looking at these values. Right? So far this is clear?
Yes, sir.
Okay. Okay, now the next thing is, notice in each of the questions, we are not only talking about the rate of change of volume, but we are talking about the rate of change of level of water or height of water. So that means we have to find some kind of relationship between volume of water and height. So it's what kind of tank? It's cylindrical. So it's very easy. Volume should be equal to height into area, and area is given to us as constant. So we'll make use of this also. We'll make use of this simple formula that in a cylindrical tank, if the height of the liquid is h, then the total volume of liquid is how much? It is area of the base multiplied by height. So this might seem like a very simple point over here, but you'll see it becomes very relevant because we are going to calculate all these things. We are going to calculate that at what rate the level is changing. That means the height is changing. Okay. And again, we are going to calculate at the rate at which the level is increasing or the level is changing and all these things. Okay. So this is about the question. Yeah.
Like if you have to calculate the rate at which the level is changing, then over there we'll first take out the height of water, like what it was initially at 0, and the other one at 1 minute, and then h2 minus h1 upon 60 seconds in the first case, right?
Yes, we can do that also. Okay. Or we can also do a little bit of a shortcut, okay, which I'm going to show you next. But what you're saying is correct. Like we can find out h1 and h2 at 2 points of time, t1 and t2, and we can just write the rate of change as h2 minus h1 upon t2 minus t1. Now, why we can do that is because the rate of change is uniform. Okay, so it doesn't matter whether we are talking about instantaneous rate of change or average rate of change. They're both the same. This point is clear now?
Yes, sir.
Like if suppose the inlet tap was not a uniform tap, that it's letting water at a uniform rate, but it was the rate at which volume is coming is changing with respect to time. Sometimes more water is coming, sometimes less. Then the question would not have been so simple like this is. Okay. Then we would have had to use differentiation and all that. But at this stage, we had not learned differentiation. So I gave you a simple question which has to do with uniform rate of change. So uniform rate of change, again, the best way to analyze it is think in terms of graph. Okay. So I'll just discuss a little further about this question. So worksheet 1, question number 2. So let's say this is the side view of the cylindrical tank, okay, which is open. The base area is given to us as 50 centimeters square. Now, initially at t equal to 0, the volume is 0, it's empty. Okay, but let's say we have a tap here and we start letting water in. Okay. So it's letting the rate over here is 4 cc per second, cubic centimeters per second. So what will happen is after some time, and I'm talking about within the 2 minutes, so no leakage has developed yet. So if I look at some later time, which is less than 2 minutes, less than equal to 2 minutes. So now t is less than equal to 120 seconds. So at this rate, there'll be some kind of this thing and only inlet is happening. So the volume, this will be increasing with time. The height, this will be increasing with time. Okay. So I know that from 0 to 120 seconds, okay, the rate of change of volume with respect to time is how much? It is 4 cubic centimeters per second. So what I can say about volume as a function of time, it should be 40 in cubic centimeters.
Yes, sir.
Okay. And further, what I can say about the height of liquid, Okay, volume is equal to area into height. So the height should be equal to 4t divided by the area. So this is in cc divided by centimeter square. So it will become 0.08 t in centimeters. So I'm seeing how the height is changing with respect to time. But of course, in this time interval. So now we can visualize the rate of change for both of these things. If we are thinking about how volume is changing with time, okay, it's starting from 0, initially empty tha, but it's rising at a uniform rate such that at 120 seconds, the volume would have become how much? 120 into 4, so 480 cc. Okay. And in general, the volume is equal to 4t as a function of time. But similarly, if I look at the height as a function of time, it's a very similar graph, because if volume is changing uniformly, so is height with respect to time. So the height is also changing uniformly with time, such that at 120 seconds, the height will become how much? 120 into 0.08. So that's the same thing as 120 into 8. So yeah, 9.6 centimeters. Okay. And this is also a straight line graph. So anything that you are asked for within 120 seconds, now it's very easy to see from this graph. Okay. For example, if you ask to find the height after, let's say 60 seconds, so you have to just draw this and see what the height will be. It will be half of this. If you ask like to find the rate of change, so you can see that rate at which the height is changing, delta h by delta t, is nothing but the slope of this line. So that is equal to how much? 0.08 centimeters per second. So this is the rate at which the height is increasing in this interval of time from 0 to 120 seconds. Okay, this is clear?
Yes, sir.
Yes,
Okay,
sir.
so these questions, my idea was just to get you used to the concept of uniform rate of change and a straight line graph. The fact that straight line graph has uniform rate of change. So anything where the rate of change of a quantity is changing uniformly with time, it's very easy to visualize it as a straight line graph. Yes, beta.
So can you please repeat that last part? Slope is equals to 0.08 centimeter.
हाँ, वो कैसा है? Because see, h is equal to 0.08 t, na? Okay.
Yes, sir.
So what is the slope of this graph? Like it's starting from 0, and at any particular time t, h is 0.08 t, na? So delta h by delta t will be this factor. It's basically like a graph like this. Y is equal to, let's say, m into x. Is that type of graph, na? So what is the slope? It's m.
M.
And delta y by delta x, or y2 minus y1 upon x2 minus x1. That thing is nothing but the slope m only, right? So that m
Yes,
over
sir.
here numerically is how much? 0.08.
Yes, sir.
So that's how I know. I don't need to do any other calculation because it's a linear function, because it's a uniform rate of change. So I can see that it's very easy to calculate. Okay.
Okay, sir.
Okay. Now next, after 120 seconds, what is happening is there is a leakage that is developed. Okay. So now the level of water will start coming down. So next diagram that we draw, let's imagine that it's after 2 minutes. Okay. So now there is some leakage also that's developed somewhere, let's say. So the rate of leakage is 8 cc per second, but the inlet is still on. So this still has the uniform rate of 4 cc per second. But we can see here that the rate of leakage is more than the rate of the rate of the inlet. So we know that the level of water will now start coming down. So this is what is happening for time greater than 120 seconds. So at such a time now, we will see that the level of water, the volume, is decreasing. So the net rate of change of volume, so for t greater than 120 seconds, what we had seen is that delta V by delta T, the rate of change of volume, is the rate of the inlet pipe minus the rate of leakage. Okay. So that is equal to +4 minus of 8. So my volume is decreasing at a uniform rate of -4 cc per second. Okay. So I don't need to develop a formula. Now I can just see that in this graph, what will happen? I'll just have to extend this time axis a bit. Okay. But you will see the second half is going to be symmetrical with respect to the first half. Okay. Because the first half, the volume was increasing at this rate, Now the second half, the volume is decreasing at the same rate. So here delta V by delta T is -4. Here delta V by delta T was +4. So I know that it will empty out in how much time? It will empty out in exactly 240 seconds or 4 minutes. So the first 2 minutes, it reached the maximum volume, and thereafter the volume started decreasing, and finally it emptied out in 4 minutes. Okay. Now again, using the formula that height is equal to volume into time, so you'll see that the height will also start decreasing in the same way. And in 240 seconds, the height would have become 0. So here the slope of this delta H by delta T will become minus 0.08 centimeters per second, because here the slope was how much? Plus. Right? So you can
Yes,
see that.
sir.
So now I can directly see here that this basically means, so volume is equal to area into height, but area is constant, remember. So I can directly relate this, that any change in volume is equal to that constant area multiplied by equivalent change in height. So the relationship between these two is that delta V by delta T is equal to area times delta H by delta T. Okay. So delta H by delta T is going to be 1 upon A times delta V by delta T. That's another way to show that it is. Now this rate has become, for this second interval of time, this rate has become -4 cc per second. Okay, and this is, so that's why this has become minus 0.08 centimeters per second. So the height starts decreasing at the rate of 0.8 millimeters or 0.08 centimeters per second, whereas initially it was increasing at this rate. And now from these two graphs, you can answer all the questions. Whether you are asked the rate of change of the height or the value of the height at some time or anything like that, you can directly answer from the graphs. Right? Is it clear?
Yes, sir.
Yes, sir.
Now, the interesting thing is you'll see that if you go back to this worksheet, after all the new knowledge that you gained about calculus and differentiation, you'll see that all this seems much easier. At the time when we had started this worksheet, we had not learned all the formula of differentiation and all that. So we had to really think carefully about how to use this concept of slope of the tangent or slope of a straight line, uniform rate of change and all that. But now that we have learned a little bit more about differentiation and the more applications of differentiation you'll see that these type of questions will become very elementary for us. They're very basic in that sense. And after a while, this will become very obvious that this should be a graph with a straight line going up like this, then a straight line coming down like this. The slope of the straight line should be the rate of change, so that you can see logically. And initially, the rate of change is the rate at which water is coming in. But finally, the rate of change is negative of the leakage plus of the inlet, like that. Okay, so I hope all the parts are clear for this question.
Yes, sir.
Yes,
okay, very good. Okay, now this question was the one where basically we are not calculating instantaneous rate of change by differentiation method. Yeah, that's correct. You can calculate at any instant of time the volume. In the previous question, we can calculate the volume at any instant by just using that graph. Yeah, that's correct. Yeah. So,
sir, this question we had done in class, right?
We have done this type of question in class. Okay, so this was just an additional homework sort of thing for you. So this part where we are calculating the instantaneous rate of change, now we know how to calculate by differentiation. But at that stage, we had to define the instantaneous rate of change like this, that delta y by delta x, but delta x very small, not even tending to 0, but very small. Okay. So when we did this, we would have gotten approximate value of instantaneous rate of change. Now we know that for exact value of rate of change, we can just do differentiation. So differentiation of this function you can see is 2x minus 2. Okay. So instantaneous rate of change at a particular point will come according to this formula now. So you can go back and compare the answer that you got when you took delta x as a small value like this, and you got the approximate value of instantaneous rate of change. And now using differentiation, when you get the exact value of rate of change, you can see how they compare. And you'll see that they're more or less the same, just that this one is 100% accurate, this one is a bit approximated. So that was this question. Okay. And then this was just about interpretation of graphs. So I hope all of you got this. Okay.
Yes,
so
sir.
what you have to understand is that this part of the graph from here to here, we will treat it like a straight line. So it has a uniform slope. Okay. So it has uniform slope. So the slope here we are talking about is delta S by delta T. So that means it has a uniform speed. Okay. But this part of the graph above, from here to here, this part, you can see it is a curve with decreasing slope. So decreasing slope here means that the velocity is decreasing. Whereas this earlier part of the graph, this part, here to here, you can see it has an increasing slope. So that means your V is increasing. Yes?
Yes, sir.
So that is how you could answer all these things. Okay. So I think if you just go through the hints and solutions that I've sent, again, they should be pretty easy for you to work out. Okay. So we'll conclude the discussion of the assignment sheet with this. I think all the questions must be clear to all of you.
Yes, sir.
Okay.
Yes, sir. Thank you.
Yeah, any doubt, beta? All right. So moving ahead, clear all this. Come back to. Okay, so let's see how far we reached in differentiation. So far we have seen one basic formula of differentiation, that differentiation of x to the power n is given by this formula. And we have seen some properties. Differentiation of a constant is 0. Differentiation of a constant multiplied by a function becomes the constant times differentiation of the function. And we have seen that differentiation of the sum or difference of two functions, like the distributive property, is differentiation of the first function plus or minus differentiation of the second function. Now we will build further on these properties and formulate a little bit today. Okay. So these three properties we've seen, and this particular formula so far. Now before we go ahead, we'll also see that we'll use a short form notation. That differentiation of a function in short form can be just written as prime of that function. Okay. So this is a shorthand symbol for this whole operation. Okay. So this is the short notation of what we have on the right hand side. Sorry, on the left hand side, which is the differentiation of the function. Okay. And it is also given a special name. It is given the name f prime x, which is rate of change of fx, is also called the derivative, okay, of fx. So for example, we say that derivative of, let's say, a function x cube is 3x square. So 3x square is the derivative of the function x cube. So that's just another way of expressing these terms. So if our function is x cubed, then its derivative, how do we get the derivative? By applying differentiation. So by applying differentiation on x cubed, we see it comes out to be 3x squared. So specifically, what do we call 3x squared in terms of x cubed? We say that 3x squared is the derivative of x cubed. Okay. So nothing extraordinary here. It's just a name. And you'll see that this kind of nomenclature or this kind of notation will make things easier for us as we develop more formulae and theorems.
Sir, can you wait? We have to write.
Yeah. This part you can write now. Okay. Whereas these things you have seen last time only. It's just a recap of.
What is the heading you have written? Short?
Sorry? Short form notation. Short form, shorthand, whatever.
Sir, completed.
Okay.
Sir, done.
Please
No,
wait.
sir, not done.
Yeah, no problem. Just write this down. Okay. So as you're writing this down, you can just try and one more example. So find the derivative for the following functions. So this actually means the same thing as differentiate the following functions, because differentiation operation only gives us something which we call the derivative. So so if you finish writing this down, just work out the answers of these three. Again, they are very similar to the questions we've discussed last time. So there's nothing new yet. Okay.
Sir, they are similar to like same as dy upon dx, but just we use a different notation over there, right?
Just we are using the name derivative now. But derivative का meaning क्या होता है? It's that dy by dx only, है ना?
Yes, sir.
Sir, we will differentiate each term separately.
Right? Each term you have to give a separate answer. So the first part of the question, dy by dx is derivative of the function x square root x. Second part, it is 1 upon 2 cube root of x. That symbol with the square root symbol with the 3 written inside, it means cube root, right? So for example, cube root of 8 is 2, because 2 cube is 8, like that.
Sir, can you please solve?
Yeah. So have you got the answers, people? Just check your answers. Yes, very good. Rishita, first one is correct. 5 by 2 x to the power 3 by 2 or 5 by 2 x root x. I'll just put up the answers first. You try to work them out yourself correctly. So this one should give me the derivative as this. Okay. So this is the derivative of this.
Sir, this 5 upon 2, how you are getting?
I'll explain. Okay, I'll step by step I'll show you. But just remember, it's application of this formula. Differentiation of x to the power n is nx to the power n minus 1. Nothing else. We just use this formula.
Sir.
Yes.
Sir, this 5 by 2, could we write it in points like 2.5?
You can write it in points. It's no problem. That's the same thing. So there are many different ways we can express it. You can write it as 2.5 x to the power 3 by 2. You can write it as 2.5 x to the power 1.5. You can write it as 2.5 x root x. So many different ways we can write it. That's fine.
So now you get 5 upon 2.
Yeah, I'll explain. I told you that you have to apply this formula. Try to work it out yourself because this is the second day that we're doing this type of questions. So if you just apply the concepts we learned in the last lecture, you should be able to work this out yourself. I will give you this working in just a bit of time, but want you to please try this out. Try to get it yourself. Yes, anyone got the answer to the second part?
Oh.
Yes, very good. That's correct, Rishita.
Sir, I really didn't got that. How do you got that 5 upon 2?
I'll explain it. I'll explain. Okay. Thoda sa, if you have the last lecture's notes now, last 3 or 4 problems, go through it. You might be able to solve it yourself. Now again, there are different ways we can express this. I've just given one form of expressing this. Okay. So I'm waiting for the third one's answer also. Don't worry, I'll solve these step by step for all of you, but I just want you to give it a good try yourself. Okay.
Sir?
Yeah.
Sir,
yeah, very good. Number of people have got this correct. 2x minus 2 should be the answer for this. Very good. Yes, tell me, Vita, what was your doubt?
nothing, sir. Understood.
Understood? Okay. You are verifying this answer? Okay.
Sir, I was doing the second one.
Okay, okay. So let's come to each of these. Okay. Now I'm explaining step by step each one. So the first one, y was x square root x. Now here we'll use a property of indices that x to the power a into x to the power b is x to the power a plus b. This is a property of indices, and that root x is x to the power half. Okay. So that is why x square root x can be written as x to the power 2 into x to the power half, which is x to the power 2 plus half, which is basically x to the power 5 by 2 or 2.5x. I mean, x to the power 2.5. Okay. So hope now all of you understood how we got in the derivative. We got
Yes,
5 by 2.
Yes,
Got it?
sir.
Because the power n is only 5 by 2. So derivative of this now. So in the language of calculus, now we said this is the derivative of y or differentiation of y with respect to x. So this becomes n x to the power n minus 1 if I'm writing all the steps. So 5 by 2 x to the power 3 by 2. So as far as your answer is concerned, this is correct. But you should also know that this can also be written as this. So these are all alternate forms of writing it. Okay. Now, since you have to get used to MCQ questions, which means the answer will not be written by you. You have to select the correct answer. So the answer might be given as this. It might be given as this. It might be given as this. So you have to know that all of them are equivalent to each other. So that will come with experience in problem solving. Don't worry.
Sir, just wait.
Yeah. Second one. So we should understand that this is cube root of E. So basically what it means is that if this, then it means that A is equal to B cube. So alternately, this also means that so this means here that y is equal to 1 by 2 into 1 by x to the power 1 by 3. So that is, so we have to interpret y this way, that y is x to the power minus 1 by 3 divided by 2. Now, once we've expressed it this way, we can see that it is a function into a constant, where the constant is half and the function is x to the power n time. So that's how we use the differentiation operator. So first step, we can take the 1 by 2 outside because it's a constant. So 1 by 2 into n, x to the power n minus 1. So that's how we got, so 1 by 3, not 1 by 2. The power is minus 1 by 3. So that's how we got this minus 1 by 6 factor. And so again, this is the answer, but we can also express it as, bring this to the denominator, and we can also express this as 1 by 6 cube root of x to the power 4. So many different ways in which we can express it. Or we can also express it as 1 by 6 x into cube root of x. Because x to the power 4 by 3 can also be written as this.
So this you're using of that formula, no? D divided by d dx x raised to the power n.
Yes, we are using that formula over here. So n का value यहाँ पे कितना है? -3, -1 by 3. That's how.
Sir, -1 divided by 6x raised to 4 upon 3. That in that, so 3 becomes the square root of that.
Sorry, beta, little bit louder, please.
Sir, I said -1 upon 6x raised to the power of 4 upon 3. That is there. So, sir, 4 upon 3, that 3 you have become the cube root now of that answer.
It's become the cube root because see, cube root is power 1 by 3 ना. So 4 by 3 को मैं क्या लिख सकता हूँ? X to the power 4 whole to the power 1 by 3.
Yes, sir. Yes.
So then I can take a cube root and take inside the cube root x to the power 4.
Yes, sir.
Okay, so again, actually, there is like a hidden step over there that x to the power a by b can be written as x to the power a whole to the power 1 by b. Okay, so that's why x to the power 4 by 3 can be written as x to the power 4 whole to the power 1 by 3. So that is cube root of x to the power 4. Okay, now we are doing a lot of these type of algebraic calculations, which at this stage will seem a little bit complicated to you. But when we use calculus in physics, generally we don't come across such complicated things. You know, it's going to be differentiation of quadratic functions, cubic functions, simple type of powers, not something excessively complicated like this one. But still, just for the sake of complete knowledge, we should know how to differentiate something like this. It's not every day we'll come across something like this in our physics application. It's very rarely. Okay. The more common type of applications are like the last part of this question. where I just gave you a simple quadratic function to differentiate. It was x square minus 2x plus 3. So this is more like an everyday kind of problem that you'll be seeing in physics. So for this one's derivative, we'll just apply the properties of differentiation before we apply formulae. So you can see that there are three different terms. So we have to separate them out. So first step is the distributive property. Okay. Now in the second step, this 2 is constant. So bring it out. Okay. And the third one, we're going to apply the property that differentiation of a constant is 0. There's a constant. So we use the property that differentiation of a constant is 0. Rest is all formula based. So 2x. So this becomes final answer. So this is the derivative of y.
Yes, sir, got it.
Okay.
Done, sir.
Okay, very good.
Sir, 1 minute.
Yeah. Just a moment.
Sir, just 1 minute. Huh?
Yeah.
So here the value of x also you have took as 0.
Sorry, which value?
Sir, you wrote not 2x minus 2 into 1 plus 0. That
2x minus 2.
Sir, you've
Into
used that
1.
nx raised to n minus 1 formula here, right? In the end.
For which part? The differentiation of x square? Yes.
Yes, sir. The end. In the end.
And then differentiation of x is equal to 1. That is also that formula only. No, because x can be written. I mean, if I have x just like this, it's the same thing as x to the power 1. So differentiation of this thing will be 1 into x to the power 1 minus 1. Right? So that's 1. All right, is it clear?
Yes, sir.
Okay. And this third thing is 0. Why? Because 3 is a constant. So we know that differentiation of a constant is 0. This is a property of differentiation. Okay. Now, some additional formulae we'll learn today. Differentiation or derivative of trigonometric functions. Let's see basic examples of trigonometric functions. Y is equal to sine x. Okay. It is also called the sine function. Like we have the name quadratic function, linear function, like that. This function is called the sine function. Okay. Its basic graph looks like this. So at this stage, I'm just giving you the absolute basic graph from 0 to 90 degrees, or what we call pi by 2. At a later stage, we will also see how the graph extends to larger values of x. So this is the graph of y equal to sine x. So 90 degrees is the same thing as pi by 2 radians. For example, pi by 4 is 45 degrees. At 45, the value is 1 by root 2, which is approximately 0.7. Then similarly at 30 degrees, which is pi by 6, the value is half, or 0.5. So here x is expressed in radians, which is basically what we call the standard international unit, SI unit, or also in degrees, where the conversion factor you should know is that pi radians equals to 180 degrees. So accordingly, 90 degrees is pi by 2, 45 degrees is pi by 4, 30 degrees is pi by 6. Another common value that all of you know is 60 degrees, which is pi by 3. So know that sine 60 is root 3 by 2.
Excuse me, sir.
Yes.
So I was facing a terrible network issue. My network got crashed. Can you please say what you were explaining?
Yeah, I'll send you the recording, but it's just basically this information about the basic sine graph. We are discussing about basic trigonometric functions. So the first one is the sine function. So sine function is y is equal to sine x. So if we substitute the value of the value of x, anything between 0 and pi by 2, the value of y is anything between 0 and 1. And these are some specific values that you should know.
Okay, sir, done.
Then of course, the most fundamental one, sine 0 is 0. Now, derivative of sine function. Equals to cos x.
Sir, means d upon dx sine of x can be also written as cos x.
Yes, but that is the formula. Just like we have differentiation of x square is 2x. So this is basically the operation of differentiation. If we input the function x square, the output that we get from this operation is the derivative, which comes out to be 2x. So similarly, if we input the function sine x, the output that we get f prime x, or the derivative, happens to be cos x.
Sir, can you give an example?
So this itself is the fundamental formula, no, beta? So it basically means that if y is equal to sine x, it means that dy by dx is cos x. Just like if y is equal to x square, it means dy by dx is 2x. You're understanding the point, right?
Yes.
Sir, this relation of input and output is just in between sin x and cos x.
Yeah, so just like for the fundamental trigonometric function of sine x, the derivative is cos x. Like that, we have formula for all the other trigonometric functions also, like the cos function, the tan function, the cosec function, right?
So are we going to study them?
Yeah, we are going to be studying all of them. So this is the first one. Okay.
Sir,
yes.
Sir, degrees are applicable here, like sine 43x or something.
Sorry, come again.
Sir, degrees, angles are applicable here, like sine 43x, sine 57x.
Sine of what?
Sir, like complementary angles, in this case, there is applicable like something complementary angles.
Complementary angles, no, but this is just a case of we are telling what are the values of sine for different values of x. No? So complementary angles doesn't really apply over here.
Okay, sir, thank you.
Sir, so for this we have general formula or we have to by?
Sorry, come again, general formula?
Sir, means in this also we, means to find some functions we have any formula?
This is the formula, no, beta. This formula that we boxed over here, this is the formula we'll use whenever we are dealing with the sine function. So the application of this is this, that if y is equal to sine x, then dy by dx is how much? It's cos x.
So d by dx cos x will be?
That is something different. We'll come to that, beta. But this is, so far we have seen only the first formula of trigonometric functions. That is when the function is sine x, then what is the derivative? It is cos x. Understood?
Okay.
Okay. Yeah, Piyu,
Sir,
what was
could
your
you explain me the input and output that you wrote?
Yeah, see, differentiation is a process, no? It's an operation. So operation mein when we input a function, what is the output we get after doing the operation? We get the derivative of the function. Understood?
Okay. Sir, while solving, we will be given the value of x, right?
Depends, no? Whether we are finding the derivative of the function or we are finding the value of the derivative at some point.
Okay, sir.
You got my point? Like that question we were doing today, that suppose s is given to us as 10t plus t square, and we are just asked to find the instantaneous velocity. So then that is directly the derivative of this. So that is going to be 10 plus 2t. But if we are asked to find the instantaneous velocity at t equal to 5 seconds, that means in this formula, we have to substitute t as how much? 5 seconds.
Yes, sir, yes.
Then that particular value will become how much? 10 plus 2 into 5, so it will become 20 meters per second. So in general, when we say derivative of a function, we mean this thing, ds by dt in this case, or dy by dx in this case. But if I say, okay, what is the value of the derivative at x equal to something like pi by 4, then that is nothing but cos pi by 4. Okay, so hope the point is clear, beta?
Yes, sir.
Okay. So again, you know, for example, if I say that, let's say I have something like this. I have a function given to me as 2 sine x plus 3. Okay. So I want to find out, first of all, the value of y at x equal to, let's say, pi by 6. And secondly, I want to find the derivative of this function, which is basically just, I want to find out dy by dx. And then I also want to find the slope of the tangent for this function at the point.
So it's the graph.
Yeah, at the point x equal to pi by 6, let's say. So how we are going to find this last part, the slope of the tangent at that particular point x equal to pi by 6, it will be the value of the derivative at x equal to pi by 6. So that means it will be the value of dy by dx, but at a particular point x equal to pi by 6. So that's how we calculate this. No, that is the meaning of this question. So now let's work out each part of this. Okay. So first part you can see, I want to find y for x equal to pi by 6. Okay. So y will become 2 sine pi by 6 plus 3. Now you know from your knowledge of trigonometry that sine pi by 6 is the same thing as sine 30 is equal to half. How we know this? Because we know that a right angle triangle which has the ratio of perpendicular to hypotenuse equal to 1 by 2 has the value of this angle theta equal to 30 degrees. I know this. This is about trigonometry of right angle triangles. Okay. So from that I know that this is half. So I'll substitute that over here. So this will become 2 into half plus 3. So as you can see, that will be 4. So I know that y is equal to 4 at x equal to pi by 6. Okay, so this first part is nothing to do with derivative. It's just about value of the function. Is the value of y for a given value of x. Now the second part, what we'll use differentiation, and in that which formula we'll use, the formula we just saw, that differentiation of sine x or derivative of sine x is cos x. So this is what we'll use for the second part. This basic formula. Okay. And in the third part, once you've got the derivative, we'll just plug in the value of x as how much, pi by 6, to find what is the slope of tangent at that point pi by 6. Okay, so hope it is clear what I'm saying over here.
Yes, sir.
Okay. So just,
Yes, sir. Could you please wait so that we can cope up with you?
Yes, yes. Try this out. Yes.
So, sir, whenever it will ask like about derivative, we will simply write cos x.
If the function is sine x, then the derivative is cos x. But here the function is not sine x. No? It is twice of sine x plus 3. So the derivative will be slightly different, right? We'll have to use the properties of differentiation also. Understood? Okay, no? Like see, the derivative of x square is 2x. Okay. So what is the derivative of 3x square? It's 6x.
Yes, sir.
So something like that we'll have to use here also. So the properties we had learned earlier of differentiation, that you use along with this fundamental formula, that what is differentiation of sine x? It is cos x. Just like till now we were using the fundamental formula that differentiation of x to the power n is nx to the power n minus 1. So now instead of x to the power n, if we are differentiating sine x, then what is the value? It is cos x. What is the derivative's value? It is cos x. Okay, so let's see what is the answer. Yes, very good. Rishita, your answer is correct. Swayam, your answer is correct. So pi is equal to 2 sin x plus 3. So now we want to find the derivative. So we have to differentiate this whole function 2 sin x plus 3. So first we'll use the distributive property of differentiation. We have a plus sign in between, so take the differentiation operator inside the bracket.
So when we have constant, so that it means that we have to use distributive.
When we have constant,
so then we have to use that distributive property.
Yeah, I mean, there's a plus sign in between, so you have to use the distributive property. But the second term is a constant anyway. So you know that differentiation of a constant will give you 0. That's how this is becoming 0. Okay. Whereas the first term itself is 2 into sin x. So 2 is again another constant, so we'll bring it outside. And now we'll use the fundamental formula that differentiation of sin x is what? It's cos x. So it is 2 cos x plus 0. Okay. So differentiation of this function or the derivative of this function is becoming this. So y equal to 2 sin x plus 3 means that dy by dx is equal to 2 cos x. So this is what we say is the derivative of the given function So now the third part, we have to find the slope of tangent.
So please wait.
Of this graph y equal to 2 sin x plus 3 at the point x equal to pi by 6. Okay. So basically what is slope of tangent? It is the value of the derivative. Okay. It is the value of the derivative. And by derivative, we mean dy by dx. Okay. At the point x equal to pi by 6. So basically it is equal to 2 cos pi by 6. Okay. Now cos pi by 6 you know is root 3 by 2. So this is root 3. Okay. So the slope of the tangent at that point is in fact equal to this. So this is the slope of tangent at x equal to pi by 6. Now this value of cos pi by 6 is again fundamental trigonometry. You know that if this angle is 30, then perpendicular base and hypotenuse are in this kind of ratio. They are in the ratio is like this. Okay, so therefore sine 30 is half, cos 30 is root 3 by 2, tan 30 is 1 by root 3. So these are all defined as perpendicular upon hypotenuse, base upon hypotenuse, perpendicular upon base.
So can you scroll up for question?
But the question is here itself. No? See, I've given you the function. So the third part of the question was this, that we have to find the slope of the tangent at the point x equal to pi by 6. This is the question only. And this is the answer to it, right?
Okay, sir.
So we have everything here.
Sir, I was writing up.
Writing? This part now is there, but I'm not doing it. So also, what do we mean exactly by the slope of the tangent? No, because after all, tangent is a geometrical thing. No? So we have to understand what we mean by it geometrically. So what we mean is, earlier we were talking about the graph of that function sin x. So here the function is going to be a little bit different because it is 2 sin x plus cos x. Sorry, 2 sin x plus 3. So the graph will in fact be something like this. Okay. So now for this graph, if I draw the point pi by 6 and I make a tangent at that point. So this tangent at x equal to pi by 6 will have a slope equal to root 3. That is the meaning of this term.
Sir, मुझे नहीं कुछ भी नहीं समझा.
Sorry, beta, a little louder, please.
So I didn't understood.
Understood which part, beta?
Sir, this root 3 you were showing that.
Beta, you have to speak a little bit louder. I can't hear you. Can you come closer to your mic?
Yes, sir. Am I audible now?
Yeah, now you're audible.
Yes, I was telling that graph one. Could you re-explain?
So what is the meaning of slope of tangent? So if this is the graph of the function, this blue colored curve, this is the graph of the function y is equal to whatever 2 sine x plus 3. So at the point x equal to pi by 6, if I draw a tangent, then what will be the slope of that tangent? That is root 3. So that is the meaning of this thing. That is the meaning of this question, that we want to find the slope of tangent at this point. So how do we calculate it? Dy by dx at x equal to pi by 3. But what it means that if I draw the tangent line at that point, that line will have a slope which is equal to root 3. Is it clear now?
Yes.
Okay, so this question is fully clear, I hope.
Yes, sir.
Yes, sir.
Yes.
One more formula we'll see today before we conclude. Okay. So just like we've seen the basic trigonometric function of the sine graph. Okay. Now we'll see the second basic trigonometric function called the cosine function. So the cosine function is y is equal to cos x. And as you know, the graph of the cos x function, now I'm just drawing the basic graph for 0 to 90 degrees or 0 to pi by 2 radian. So this has kind of like the opposite behavior of sine x. It comes down from 1 to 0 as x goes from 0 to 90 or 0 to pi by 2. So this one's behavior is like this. It's kind of like the reverse of the behavior of sine x. So cos 0 is equal to 1. Okay. Cos pi by 6 is equal to root 3 by 2. Cos pi by 4 is 1 by root 2. Cos pi by 3 or 60 degrees is half. And cos pi by 2 or 90 degrees is 0. This is pi by 2 or 90 degrees. This is, let's say, pi by 4 or 45 degrees. So here the value is 1 by root 2. So now this cosine function has derivative given by the formula differentiation of cos x or derivative of cos x is minus sine x. So this is the second of our fundamental trigonometric definitions. Sine x's differentiation is cos x, but cos x's differentiation is minus sine x. So for example, for y equal to cos x, find slope of tangent at the point x equal to pi by 3, suppose. So we will see that dy by dx or derivative of the function from the formula I've just given you above is minus sine x. So therefore, slope of the tangent at x equal to pi by 3 is the value of dy by dx at x equal to pi by 3. So it is minus sine pi by 3. So it is negative of root 3 by 2. That should not come as a surprise that it's negative, because you can see the shape of the cos graph now. The shape of the cos graph is a curve like this. So obviously my pi by 3 is lying somewhere over here. So when I draw the tangent at this point, it has a negative slope, you can see. The slope of the tangent here for this point is negative of root 3 by 2. So it is because of the very nature of the cos graph. Because the cos graph's value is decreasing from 1 to 0 as is going from 0 to pi by 2. So at any point between 0 and pi by 2, like pi by 3 over here, if I draw the tangent, it will have a negative slope. So that you can see it's reflected in the formula. Whereas earlier the sin x graph we had seen, its graph shape was such that its slope was positive between 0 and 90. For y equal to sin x, we saw that the slope at any point will have a positive value. So we saw that dy by dx was cos x for this graph. But this is different now. This is the cos graph. So its derivative is having a negative slope. I mean, its derivative is negative because its slope is negative at such points. So the formula that gives us the value of the derivative is in fact minus sin x.
So done.
Okay, so we have learned two of the fundamental trigonometric functions derivatives today. Sin x's derivative is cos x and cos x derivative is minus sin x. Okay. So it's first of all important that you remember these values. Okay, don't mix up the minus sign. Always keep in mind the graph. It's easy to remember that why the cos x graph has a negative slope. So differentiation of cos x comes with minus sign. It's minus sin x. Whereas the sin x graph is this graph over here, this one. It has a positive differentiation is cos x. Okay. And apart from that, any function which is a combination of these two things, we can use all the properties that we've learned earlier. So now, for example, suppose we have a function like this. Y is equal to 2 sin x plus 3 cos x this time. Let's say. So then what is dy by dx? So we'll just use the properties and the formula. So you can see that here, when we are operating differentiation on this function, we'll just use the properties that it is take the 2 outside into differentiation of sin x plus take the 3 outside because it's a constant into differentiation of cos x. And now use the formula that we've just discussed, that derivative of sin x is cos x, whereas derivative of cos x is minus sin x. So differentiation of this function becomes 2 cos x minus 3 sin x. So dy by dx becomes this. So this becomes the answer to this part.
Sir, understood.
Sorry, any doubt?
No, sir.
Okay, this is clear. No? Yes, very good. All right, people. So we will conclude here today, and I'll be sending you another worksheet which will have application of the formula of differentiation and the properties that we've learned so far, like the distributive property we've used here. Okay, the property that a constant into a function, when we differentiate, the constant comes outside, all these kind of things. Okay. So I will send you the worksheet and I'll send you the hints and answers after a couple of days. So make sure between tomorrow and day after, you work out the questions of the worksheet before I send the answer key. So you can verify your answers and any questions you couldn't attempt, you can try it from the hints.
So will you send the video
So you will give worksheet today, a new one to practice.
Yes, I will send a new worksheet today. Okay.
Thank
So
you.
in the next 2 days, just make sure you attempt the questions of the worksheet. Okay.
Sir, do we have to upload the worksheet somewhere?
Yes, you have to also upload the solutions of the worksheet that you make. Okay. As an assignment, right?
Sir, where?
On the website, but on the planner app, na?
Sir?
Okay.
Yes.
Sir, I actually lost my network in the midst of the lecture for at least some 10 to 15 minutes. So, will you send us the recording of the lecture?
Yeah, I'll be sending the recording as soon as it is uploaded. Okay.
Thank you, sir.
Okay.
Bye, sir.
Okay. Okay, so that's
Thank
it
you,
for today.
sir.
People. Yeah.
Bye.
Wish you all the best.
Thank you, sir. Have a great evening.
Thank you. Same to you. Have a
Thank you,
great evening.
sir.
Okay. Okay. Bye.
Thank you, sir.
Thank you, sir.